Hi, everyone. One sec. Hi, everyone. My name is Hailey Stevens.
I'm Varun Shourie.
And thank you for joining us today, and welcome to the Introduction to Machine Learning presentation. Today, we'll start off with an overview of what actually is machine learning. Then we'll share some information about what types of roles and processes are involved in a machine learning project. Following that, we'll provide a little bit of information about AWS SageMaker and some of the tech stacks that are involved in machine learning projects. Finally, we'll end with example use cases and some learning resources. So what actually is machine learning? One definition is that machine learning is a subset of artificial intelligence. Another definition is that machine learning is the process of developing an algorithm to perform a task, such as like making a prediction, but without providing that model with explicit instructions on how to perform that task. Another definition of machine learning is it's an intersection of statistics, math, and computer science, with a heavy emphasis on the math. There's a pretty standard process that is typically followed when you create a machine learning model, and a simplified version of that process is shown here. The first step in the simplified process is to split your data into two different sets. You want a training set and a test set. You use your training data to build your model, and once your model's built, you use your test data to evaluate it. And it's really important for you to test your model on data other than that which was used to train it, because you don't want your model to overfit the training data. And we have an example slide in the appendix that explains what that means. But really, it's just you want your model to be able to make predictions on new data rather than being too closely tied to that training data. So once you're happy with your model is when you can finally use it for prediction. But this is a very iterative process. The first model that you build is probably not going to be the model that you use for your final predictions. There are three main categories of machine learning. You have supervised learning, unsupervised learning, and reinforcement learning. For supervised learning, your model is trained with data where you know what the output is supposed to be. So for example, if you're trying to predict someone's height, your training data will have records that have height available. Unsupervised learning is kind of the opposite of that. You don't really know what that outcome is supposed to be. So the model tries to do things like look at patterns in the data or how the data is structured. For reinforcement learning, the model kind of learns by trial and error, and it tries to optimize the outcome of different actions that you allow that model to perform. So for some examples, for supervised learning, an example of a model would be you might forecast future student enrollment for a new degree program. For reinforcement learning, you might train one of those little robots around campus to navigate around. And for unsupervised learning, an example might be determining what types of questions students are asking the Experience Center. So how do these machine models work? And the answer to that question is everyone's favorite answer, and it depends. So these models have different end goals in mind. And this image shows a few examples of what some models might try to accomplish. So you can imagine how the math behind each of these is going to be a little different. For a specific example, we'll go over how a simple regression model might work. So on this graph here, you see some pink dots, and in this scenario, those pink dots represent your real training data. The orange line represents the estimate from the model, And the pink boxes we'll go over next. So this particular example is for ordinary least squares linear regression. And what that means is the math behind this model is trying to find an estimate line that minimizes the sum of squared errors. So sum of squared errors is represented by the sum of those pink boxes on the graph. And each box is just the difference between the actual data point and the estimate squared, so it turns into a box. So the algorithm tries to find that estimate line where the sum of all of those boxes is minimized. And like I said earlier, the math behind all of the different types of models varies, but many of them try and go through a similar process where they try to minimize something or maximize something. So now that we have a high-level idea of what machine learning is, we should ask the question, when should it be used? Machine learning can be used when your business logic is too complex or time-consuming to code manually, or when personalization is needed. It can also be used when your results are expected to change over time. There are a couple scenarios when you shouldn't consider using machine learning as a solution. The first of which is when you're not able to acquire ample training data. Another is if you need results quickly. Machine learning projects are not quick projects by any means. And a third reason would be if you have zero tolerance for mistakes. And I want to highlight this particular scenario where maybe machine learning shouldn't be used. And we need to remember that machine learning models are not always perfect. And for example, there's a really big difference in the accuracy your model might need if your model's predicting something like if a hospital patient will be there for an extended stay versus if you have a model that's predicting like if a customer is going to buy your new product. You really need to take into account the consequences that might occur if your model delivers an incorrect prediction. And if those consequences aren't something that you're willing to face, then perhaps machine learning isn't the proper solution for your business case. Next, we'll go over some of the items that are typically involved in a machine learning project. And we'll start off by going over some of the common elements that you might see. So the first thing that I want to point out is that this image is an expanded version of that simplified process that we showed earlier. And once you have access to the slides, if you go back and forth, you'll see that the color coding kind of coincides between the two. So in a machine learning pipeline, you have to obviously start with your data. And a big part is the data exploration and testing. Here you'll research and clean your data. And again, is where you're going to split it into those test and training sets. In the next course section is when you work on actually developing your model. So here you'll build features, build your model, and evaluate it. And as this process is iterative, once you take a look at your results, you'll likely go back to that data pipeline stage, make some changes, and iterate that through that process a couple times. This back and forth is usually one of the most time-consuming parts of a machine learning project. In that final course section, the blue section, is when you start to deploy everything to production, build a pipeline to stream everything together. And I know there's a ton going on this screen, but all of these core elements can really be simplified into three different parts. And that's the data engineering, the machine learning engineering, and the software development and deployment. So each of these three core elements are something that can have an impact on your end results if any changes are made to them. And because of that, it's really important that you track those changes using version control. Next, we'll go over some of the roles that are common in machine learning projects. And the roles that you might have are going to differ depending on where your organization is at in its machine learning journey. So this image shows some of the more common roles that are involved in machine learning projects. And it also shows where some of the skills gaps might be. You can see that for many of these roles, there's a gap in that deployment section, which was that third core element, that blue one, where you kind of throw everything together. So this is these skill gaps are an issue that's pretty common just in the industry. Because of those skill gaps, platforms such as AWS have built their machine learning products with these different roles and these skill sets in mind. And a really good example of that would be AWS's Canvas product. So Canvas is essentially a black box where anyone can easily input data, build a very simple model using like a visual interface. Low to no code is needed. And once that model is developed, your business analyst or whoever it might be can pass the actual code off to someone like a data scientist or a software engineer to further improve upon that model or to implement it into a pipeline. So no matter where you are in your machine learning journey, there are definitely resources available for you. So we've gone over some of the elements of a machine learning project. Now let's take a step back and look at the process as a whole. If you're managing a machine learning project, one resource that might be useful for you is CRISP-DM. So CRISP-DM is a standard process for completing a data mining project, and it's often applied to machine learning projects specifically. There is a slightly new version of this process that's specific to machine learning. I see this one used a little bit more, and it's good enough for our purpose today. So with this process, phase 1 and 2, you need to start out by having a understanding of your business use case. So you need to go back to those questions and say, should I really be using machine learning for this solution? Is this the right path forward for us? You also need an understanding of what data you have available and maybe what data that you would like that you're missing. Then you go into phase 3 and 4, which is where you jump into that data preparation and modeling phases. And again, those two phases are very iterative. You're going to be spending a lot of time going back and forth on those two stages. Phase 5 is model evaluation. And here you are really wanting to take a look back at your business use case and see if your results are aligning with that problem that you were initially trying to solve. In CRISP-DM, you end with deployment, and in the machine learning version of the process, there's also some additional steps for model monitoring and maintenance as well. Next, we'll go into a little bit about machine learning model operationalization, or MLOps for short. MLOps is essentially the application of DevOps principles specifically to machine learning projects. So basically what that means is it's just taking established best practices from the industry and applying them specifically to machine learning projects, adapting them a little bit so they will work with the differences. And one of the big reasons why there even is a difference between the two is those 3 core elements that we want to track: your data, your model, and your pipeline. Because we can have changes in each of those 3 core elements, we want to make sure we track that, and there's just a little bit more information in this particular process as compared to the DevOps process that you need to keep track of. Having a mature MLOps process is a really good end goal for any ML project. And this slide lists some of those best practices that we just mentioned. Automation is a big one. One of the core goals in a mature machine learning process is to have things automated. And the level of optimization in your process is a really good indicator of how mature your process actually is. These are all concepts that you want to include in a mature pipeline. And as I mentioned, automation is a big part of that maturity level. And there tends to be roughly 3 or so different levels of maturity that the industry has defined. This is an example of the first of which is a very manual process where your analyst or your data science is doing a lot of work manually. They manually clean the data, they manually build the model, manually evaluate it. And once that process is done, the model's handed over to someone who works in a dev team and the model's deployed there. So this is a very labor-intensive process. The next level is where you start to see some automation. So here you've got an automated pipeline. You also have an orchestrated experiment. And what I mean by that is the experimentation, your testing itself is still manual, but the steps that kind of link everything together are automated. So your test process just runs a little bit smoother. The final stage is the ideal maturity level, and it is very similar to the one that we just saw. But the biggest difference is that this stage takes advantage of continuous integration and continuous deployment principles. And what that really means is that your code is automatically built, tested, and deployed after it is merged. So there are a variety of components that you can include in your tech stack, depending on where your maturity level is. At minimum, you obviously need somewhere where you can store and access your data. If you're building your model yourself, you need a place where you can store your code. AWS and other products do have a lot of pre-built models that you can use. And you need a way that you can train and serve your model. A more mature version of this process is going to have everything that we just mentioned. And it's also going to have more components like source control, feature stores, or monitoring services. So these slides have shown that there is a ton of work that goes into machine learning projects. So why do we want to do that? And the answer is that there's a significant number of benefits to having those more mature systems. My 2 personal favorites are having a faster time to deployment and a faster time to error resolution. Next, I'll pass the presentation over to Varun, who will go over some examples of tech stack.
Thanks, Hailey. So when going over potential options for your machine learning tech stack, let's first start with what programming languages you can use, because if you do create models, then you will have to code. It is an unfortunate reality of doing machine learning. So the 2 languages available are Python and R. I strongly detest R for reasons I will not explain. So please just go with Python. It's a general purpose programming language. It has a large user community, large code base, whereas R is used by pretty niche group of people. So yes, enough said on that issue. So here are some libraries and frameworks that you can use with Python. Some are available in R. NumPy and SciPy are for math. Pandas and PySpark are both for large scale data processing. Scikit-learn is for your classical machine learning needs. And right now where all the pizzazz is at is with TensorFlow Keras, PyTorch, and Gensim, which are sort of emerging libraries which grow every day. And those are for deep learning and topic modeling, which is a form of unsupervised learning, respectively. So now that we've gone over some programming languages and frameworks, let's go into the Amazon Web Services stack, because that is what ET and much of ASU does work with already. Some commonly used AWS services in the machine learning space include ECR for hosting your Docker containers. Docker containers, as you all may know already, or you may not know, is like an environment where you can hold all your packages for running code in one place, all the applications and tools you need to run your models as necessary. Then we have S3, which is like Google Drive, Dropbox for storing your files. And then we have Lambdas, which are sort of connectors. They help invoke your model inference endpoints, help synchronize data, and help trigger any step functions you may have. And the rest are complicated that are used by cloud engineers. So we can move on to SageMaker. SageMaker, I'm going to slow down a bit here, is a major machine learning platform advertised by AWS as their one-stop shop. From A to Z, you should be able to build your entire machine learning pipeline on SageMaker. And here are some of the crucial features. They are kind of small, but these slides are available later for you to take a look at. But I will call out a few. Data Wrangler. Data Wrangler is used for pre-processing your data, so transforming your data, and you don't have to write any code in Data Wrangler. So the nice thing about SageMaker is that there are some low to no code tools, which is good if you want to get your hands dirty. Some other features available in SageMaker include a feature store for you to track your model variables and features, and Clarify, which is for model explainability and detecting bias in your data sets. The slide right here perfectly encapsulates the AWS machine learning stack. It can be applied for a variety of fields like computer vision, speech recognition, natural language processing, chatbots, and so much more. But we can use the existing AWS infrastructure and the frameworks, Python, to really build something special. So now that we've covered the paid options, let's go into the open source options, which can be lower cost and slightly more headaches at times. First being GitHub. If you are familiar with GitHub, it is a version control tool for your code. It allows you to maintain basically your code in different versions. It allows you to store it in different branches and extensively document your code. When you're ready to push your code into production, you'll take code from like one branch of your GitHub repository and then push it into the main branch when you're ready. So currently ASU has two machine learning repositories, both of which fall under the enterprise data analytics category, but we anticipate that to change if machine learning is more widely adopted at ASU. Then some other tools include Terraform and Jenkins. Just a quick overview of both. Terraform is used to configure your cloud and on-premises resources so that they are easily accessible and reusable, whereas Jenkins is the automation server that you can use to piece together the resources from Terraform. And an article is right there on the slide, which shows Terraform with SageMaker. For a list of other resources, the Linux Foundation's AI and Data Foundation Interactive Landscape that provides a very comprehensive list of open source tools you can use, on top of Ethical ML's list of open source libraries as well. So now that we've gone over some of the tools you can use to do machine learning, let's look at some of the use cases. First being topic modeling. That is what Hailey and I mostly do when we're not doing regular BI work. Topic modeling is a form of unsupervised learning or clustering, which finds human interpretable topics in unique unstructured documents. And the current use case for topic modeling with ET is with the Experience Center, Financial Aid and Scholarship Services, and Student Business Services. And we look at what students are reaching out to the Experience Center about, whether it be loans, scholarships, grants, holds, so on and so forth. And the way it works is you apply some topic modeling algorithm like latent dirichlet allocation, or LDA for short. And once you apply that algorithm, you can use a tool like PyLDA-Viz to visualize your clusters and interpret what those clusters mean. And as a result of doing topic modeling, we can create some cool dashboards which allow us to look at what people are reaching out about over time. So as you can see in this example, we looked at topics for student inquiries and emails, and we noticed that the main topics for emails was late fee appeals, which are sent to student business services very frequently as the semester progresses. And then the next use case is the persistence models maintained by the Actual Analytics group at the Provost's office. Phil and his team run these models. They are a set of models which predict whether a student will persist or not into the next term, meaning will a student drop out of school for some reason. And the use case of this model is that the models make their predictions and then the data is dumped into a dashboard, which will allow people to make outreach to students if necessary, if they're at risk of dropping out, whether it be poor grades or they're at risk of not paying their fees. So now that we're approaching the end of our presentation, we're going to conclude with some resources. We've included a whole bunch of resources, but ASU does have a modeling user group on Slack. The channel name is included. You can join. Phil and his team often have a lot of meetings hosted there. We also have plenty of online courses and O'Reilly books, which are free with the ASU library. We have also included useful websites, documentations, and a tutorial for Jupyter Notebook and Google Colab. Colab is a zero configuration integrated development environment for machine learning, meaning you do not have to install anything. Google gives you the IDE to use for free, and professors use it for their research. So it is very powerful when it comes with the GPU as well. So if you want to get started with machine learning, now's a good time to do so. And I'm going to pass it back to Hailey to talk about the machine learning toolkit that's currently under development.
Thanks, Varun. So the machine learning toolkit is a new product managed by Enterprise Technology. And the purpose of this product is to develop standards, processes, templates, basically just to develop resources to support sustainable machine learning models and pipelines to help out the ASU community. So like similar to how we have the analytics portal, all of our different training groups, we want to provide a product to the ASU community that will provide a solid foundation to help take these extremely complicated projects and processes and make them a little easier for the ASU community. So as this is a brand new product, our immediate next steps are planning out the milestones and what exactly we want that future state to look like. And for that, we would really love your input. So if machine learning at ASU is something that is interesting to you and you would like support with, we would really appreciate it if you completed this survey. It's very short, it's just a few questions. And if the questions don't resonate with you, there is an option for a free response as well. So with that, we've reached the end of our presentation. We are super thankful for your attendance and we are here if you have any questions.